Hey, how's it going? So following up on this podcast that we had, I wanted to work a few problems for you today. So what we're going to do is we're going to do 2 problems using just EI, UI, EG, and UG. And then I'll do 2 additional problems where we include the CQ rule, which is the change of quantifier rule. So let's look at this problem that we have on the board right here. My first premise says that for all x, if x is h, then x is I. My second premise says for all x, if x is I, then x is h. My conclusion says that for all x, x is h if and only if x is I. Now let's remember what this conclusion means. When I have a biconditional, what it's telling me is that it's both the case that if I have an x that's h, then I have an x that's I, and it's also the case that if I have an x that's I, then I have an x that's h. So we can think of it this way. This right here simply means that if x is h, then x is I, and if x is I, then x is h. So in order to get to this conclusion, my goal is going to be to try and get these 2 things so that I can, or isolated, so that I can conjunct them together and then use my rule of replacement, material equivalence. Now if we look back up in the premises, we see that I have for all x, if x is h, then x is I, and for all x, if x is I, then x is h. So in order for me to use my rules of implication, because both of these lines are being governed entirely by the quantifier, I need to use some of the new rules that we learned. Specifically, I'm going to use universal instantiation. So let's do this. On line 3, what I can do is I'm going to remove this quantifier using my universal instantiation rule. That way I can start applying my rules of implication. So on line 3, we'll write if x is h, then x is I, and that will come from line 1, universal instantiation. Remember, what universal instantiation lets me do is remove a quantifier and replace my variables that are bound by this quantifier by either a constant, another variable, or I can continue to use the same variable. In this case, since my conclusion uses the variable x, I'm going to go ahead and keep x as my variable because it's just going to make things easier on me in the long run. So I'll do the same thing that I did in line 1 with line 2. So we'll remove this quantifier, and we'll go ahead and keep the same variables, and this will be from line 2 via universal instantiation. At this point, hopefully it's pretty easy to see what we're going to do. Material equivalence tells me that if I have these 2 things conjuncted, then I'll be able to derive that through the rule of equivalence. So on line 5, that's what we'll do. We'll conjunct line 3 and 4. And that'll be from lines 3, 4 conjunction. Now all I got to do is use my rule of replacement, material equivalence, which just tells me that for all x, if x is I, and for if x is I, then x is h, that this is equivalent to So again, my rule of equivalence tells me that anytime I have a biconditional, it simply means the same thing as the conjunction of the 2 conditionals. Notice that's why it's called a biconditional. It goes both ways. It means that if I have an x that's h, then I have an x that's I, and if I have an x that's I, then I have an x that's h, which is exactly what's represented on line 5. If I have an x that's h, then I have an x that's I, and if I have an x that's I, then I have an x that's h. So I can use my rule of material equivalence to take this conjunct of the 2 conditionals, and I can display it as simply a biconditional. Now, last but not least, my conclusion tells me that it's for all x, x is h if and only if x is I. So in order to complete the proof, what I'm going to need to do is quantify what I have on line 6. And my universal generalization rule will let me do that. Okay, so now that I've re-quantified what I had on line 6 using my rule universal generalization, we can see that on line 7 I've derived exactly what my conclusion was asking for. So I've shown that indeed the problem actually is valid and I can derive the conclusion from the premises that I was given. All right, I hope that this helps out.